Okay, big day today. 9.3 is reciprocal functions. This is a function that has an x on the bottom of it. Now, this is not a polynomial because the x isn't a whole power. It isn't a variable as a whole power. You can write it as x to the negative 1. And you can think of it that way because you're literally doing reciprocals. But you're not going to see it that way ever. It's going to be written like this, y equals 1 over x, something of that form. I'm going to take numbers and plug them in for x. Now, there's one thing that I can't plug in for x. I can't plug in a 0 for x because 1 divided by 0 is undefined. So x can't be 0, so I'll plug in things that aren't in 0. I'll plug in stuff real close to 0, like 0.1, 0.5, 1, 2, 3, 4, 5, 6. You get the idea. If I plug in a 0.1, 1 divided by 0.1 is actually 10. Think about it, you're doing a reciprocal, so 1 divided by a tenth. So 1 divided by 0.1, 1 divided by a tenth is going to be 10. 1 divided by 0.5, a 0.5 is a half. So 1 divided by 0.5 is the same as 1 divided by 1/2. If the reciprocal just flips the fraction over, so you get 2. 1 divided by 1 is 1. 1 divided by 2 is a half, 0.5. 1 divided by 3 is a third. 1 divided by 4 is a fourth. You get the idea. So I'll graph those. The 0.010 is going to be like way up here. I can't actually fit on the graph very well. 0.5 comma 2 is going to be like here. Notice how this scale is counting by 2's, which is kind of weird, but it is. I'm going to live with that. 0.11, 0.2 comma 1/2, 3 comma a third, 4 comma a quarter. And this is going to keep on getting closer and closer to 0 without ever touching it. But I also can't touch the 0 as I graph it towards the left. I can't get 0, but I can get closer and closer and closer to it. This graph has two asymptotes. It has a graph that has a horizontal asymptote at 0 and a vertical asymptote at 0. If I want to plug in some negative numbers, I'll get rid of these just so I can give myself some space. If I plug in some negative numbers like negative 0.1, negative 0.5, negative 1, negative 2, well, all these values just switch. I have negative 10, negative 2, negative 1, negative 1/2. I think it's going to go on like that forever, so I have this. I have, what, negative 0.5 comma negative 1. No, negative 0.5, negative 2 is going to be here, then 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 here. You get the idea again. It's going to go like this. I didn't graph this one super well, but you hopefully get the idea. It has two asymptotes. I can show you with my calculator. Y equals 1 divided by x. There it is, two asymptotes. The domain of this is the set of all numbers x such that x isn't 0. You could probably say it can be all real numbers but 0, but this is a fine way of writing it for now. The range is the set of all numbers y such that y isn't 0. And it has asymptotes at the x-axis, which is y equals 0, and the y-axis, which is x equals 0. So the y equals 0 is really this one here. This is the y equals 0 asymptote. And there's also an asymptote at x equals 0, which is this one here. Yeah, that's your reciprocal function. That's going to be our parent function. In fact, let's see if I can make this work. I click this, drag it, just show it, hopefully. Come on, you can do it. Now? No? Not going to do it? Okay, never mind. Let's do it over here, though. Here's that function 1 over x. That 1 over x now is our parent function. It's the function that everything else is going to be based off of. And I want to show what happens is, if we take this and change the 1 on top to a 0.5, what we're really doing is like we're doing a half times 1 over x. It's the same thing. So all the y values just get cut in half, which means the y values that were really high suddenly become really short. So this 0.1 comma 10. I have the 0.1, 10 way up here. Well, that gets cut in half, it becomes 0.15. And this gets cut in half, and this gets cut in half, and everything gets half as close, but it still is going to keep that same form, still have the same asymptote, still have the same curve. It just all gets closer to the axes. And the curve becomes sharper. I'm not graphing it by hand super well right now, but if I take this one, and if I keep this one here that I have, but add 0.5 divided by x, you can see it's just steeper and closer. If I compare tables, all these table values will go 0, 1, 2, 3, all the table values here are just half of the values here, because, so they are, it's half of 1 over x. So the parent function here was dilated. This right here is our dilation by a factor of 1/2. Next, I have 2 over x plus 3. Well, hopefully you'll note, in this case, x cannot be -3. It's not that x can't be 0 anymore. 0 is not a problem. If I plug in 0, 0 plus 3 is just 3, and 2 over 3 is no issue. It's not that x can't be 0, it's that x can't be -3. And before I actually plug in points and try and graph this by hand, I want to show you what this does. In fact, we should probably pause and take a second to think about how this graph is going to look different. First of all, when I put it in my calculator, I have to do it in parentheses on the bottom. 2 divided by parentheses x plus 3. If I don't use the parentheses, 2 divided by x plus 3, the calculator will do 2 divided by x first, then add 3 to that. And that's not what this is telling me to do. Oops, didn't do that. So, let's do this. 2 divided by parentheses x plus 3. Now, if you've thought about it, hopefully you've come to the conclusion, the asymptote is moved 3 to the left. Here was the original 1 over x with this weird looking asymptote. Here's the new one. This vertical asymptote, that line isn't actually there. The graph, the calculator just kind of has to put it in there to sort of make sense to itself. And this curve is here. So if I turn off this graph, here's the 1 over x graph turned off. There's that graph all by itself. The way that I do these by hand and how you'll do these on your homework is you'll basically, I think it's best to make 2 tables. A table of numbers where the values are less than 3, in this case -3, excuse me, and a table of values where they're greater than -3. Well, numbers less than -3 are like -3.1, -3.5, 4, and 5. So I do that in my calculator. I pull up my table. I'm going to be checking just this column here. If I plug in -3.1, I get -20. Sheesh. Plug in -3.5, I get -4. Plug in a 4, should get what, 2.8, sure. 0.29, excuse me. Here, 0.29. I plug in a 5, I get 0.25. Now these aren't decimals that I can graph very accurately, but I'm just going to do the best that I can. So the point -3.1, -20. I think it's really helpful to draw this vertical asymptote first. I know there's going to be a horizontal asymptote here. The horizontal asymptote wasn't moved at all. I think it's very helpful to draw the little plus first. Well, -3.1, -20 is going to be way distinct down there. -3.5, -4, it's here. -4, -2, -4, comma, let's be -0.29, it's have to be negatives. -4, -0.29 is here. -5, -0.25 is here. And the graph's going to go, let's switch colors. The graph's going to go. And also just go. I'll pause now and leave it half in a second. I'm sure you can't wait. Okay, I'm back. We'll do the other half of this one now. I'm going to plug in numbers that are greater than -3. So that's like -2.9, -2.5, -2, -1, 0, 1, 2. I'll put all those, those are easy to do. I'll go to my table again, so y equals, and that's all still good. Plug in these numbers. -2.9, -2.5, -2, -1, 0, 1. Why not? -2.9 gives me 20. -2.5 is 4. -2 is 2. 1.6 repeating. 0.5. Negative. Nope, that's not that. I'm going to ignore that one. We're going to put that one in. So this graph has a point -2.9, 20, which I can't fit on here very well, but that's like right up here. -2.5, 4. -2, 2, 1, 1. 0.6, 1, 0.5. Yes, blue, because the last one was in blue, so we'll try that again. It's tough to graph these asymptotes really well. It's bad. So the domain of the set of all numbers x such that x is not -3, and a range set of all numbers y such that y is not 0. They won't all be that way. The asymptotes can move up and down and left and right. And these have asymptotes at x equals -3 and y equals 0. Like everything we do in this class, there's an a, h, and k. So this right here is kind of like my k value, and this right here is like my h value. So this graph, that's already graphed over here, I'm not going to bother finding the points right now. But this graph has a vertical asymptote at +5, because we know x cannot be 5. It has a horizontal asymptote at y equals 1, so it's like the original parent function was moved up 1, and that's this asymptote right here. The domain of this graph is going to be x such that x is not 5, and the range of this graph is y such that y is not 1. The domain and range are always related directly to the asymptotes. So as always, you have your a's, your h's, and your k's. Your vertical asymptote is at x equals h. Horizontal asymptote is at y equals k. There's your domain and your range. I think that takes care of this.